problems are a big part of the AP CSP exam, usually making up around a quarter to a third of the multiple choice exam. This includes problems about variables, lists, iteration, conditionals, procedures, parameters, etc. It can also include other topics like simulations, algorithms, libraries, and many more things. If you look through some practice exams, you'll usually find a couple of common tropes. For example, these types of problems can appear pretty frequently. What happens when this code runs? Move the robot. What does this procedure do? What would fix this broken code? Solve a problem using these procedures. Which of these is not possible with this code? This is just a small sample, but if you're able to do these problems, you can probably be quite prepared for this exam. So let's go ahead and do some practice problems. All right, let's start with a nice and simple one. This is the type of question that's going to be asking you which of these is not a possible value for this procedure or for this code. Now here we start with a procedure called compute, and it takes a single parameter, this number n right here. It says that assume n is an integer value. That's basically just to simplify things so you don't have to worry about fractions and things like that. Now, the question here is basically, it's giving us this procedure, and then it's asking which of these values is not a possible return value for this procedure. Now, when you see a problem like this, what you have to remember is that because we have a multiple choice, we can actually take advantage of that, and you should really try to use as many tricks as you can to take full advantage of the multiple choice. And in this case, what you can actually do is, instead of trying to figure out why one of these is not possible, what you should do is try to see if you can actually get the value for 3 of them, and the 4th one is going to be the one that's not possible. For example, let's start with this one here, 40. It's actually pretty straightforward to see how we can get to 40. If n has a value of 20, then what we'll see is that we're going to go into this if right here, right? Because 20 is greater than 10, and that is going to give us a return value of n times 2, which is 40, right? So if we have an n equals 20, we can get 40 as a result. It's pretty easy to work backwards and see, all right, how can we get to this value from what we have in the code right here? We can also do the same for d. So we already know it's not a because we found a way to get to 40, but we also know that it can't be d. D is not one of the impossible values because we can see we can get the value of 10 quite easily. If n is exactly 10, right? If n is 10, we're just going to return n. We're going to return 10. So just by making n 10 over here, we can get to a part of the code where we get 10 as a result. Now notice that if n is not greater than 10, and also n is not exactly 10, then we're going to actually end up in this else right here at the bottom. And if we have n as a negative number, for example, if n is -1, right, if n is a value -1, we end up with -1 minus 5, which equals -6, so that we can easily get to a value of -6. So it's not C, which makes it the answer is actually B. Now, you don't need to worry about why the answer is B, as in you don't really need to, it's not necessary for you to understand why you can't get to this, but I think it's still good for us to understand why that is the case. Why can we not get the answer 20? Let's think about this for a little bit. In order to get the answer 20, one of these things has to be true. If we end up over here in this return value, then n has to be 10. But we can't end up here if n is 10, because in order for us to end up here, n has to be greater than 10. So that's not an option. Now, the only way for us to get over here is for n to be exactly 10, which means that in this return value right here, the only possible value we can return is 10. And finally, for this one here, n minus 5, the only way that we end up in this else is if n is less than 10 and also not equal to 10. So n has to be 9 or lower. So we can never actually get to a situation where this will return the value 20, because this will only ever return 4 or less, right? 9 minus 5 or less than that. Now let's do a problem that's a little similar in a couple ways. This one is kind of masquerading as a problem about simulations, but it's actually a problem about conditionals. So this claims to be simulating a 6-sided die roll. Now, if you remember, you can simulate a 6-sided die roll by basically doing a random number from 1 to 6 inclusive. That's going to be 1, 2, 3, 4, 5, or 6. It's going to be one of those numbers. It's going to be random. And if you get a 1, that means that you rolled a 1 on a die, etc. So what we're doing here is we're counting how many times we get the value 1 right here versus how many times we get anything else, which is supposedly right here. Now, if you look carefully, you might notice right away that there's actually a bug in this code and it doesn't really work as intended. Now, the code is actually going to run 10 times, or rather this loop is going to run 10 times. And what it's asking here is which one of these is true about what's displayed in line 17. So this line right here. Basically, what it's asking is what's true about sum. Now, if we look at sum over here, sum is the sum of 1 plus other. And 1 is basically counting how many times we got a 1 on the die roll. And other is supposed to be counting how many times we got something other than 1. So if this was working correctly, let's say we rolled 10 dice and we got a 1 3 times. 1 would have a value of 3 and other would have a value of 7 because we rolled a 1 3 times and then the other 7 times we rolled 2, 3, 4, 5, or 6. That's if this was working correctly. However, this is not working correctly, and you can actually see that because after we fail to roll a 1, so if we don't get over here, we do go into this else, but only if a second dice roll that we do right after that is not equal to 1. So what happens if we roll a 1? So let's say here's our dice, and we get a 1. We end up here just fine. But what if instead we roll a 2? And then right after rolling the 2, we didn't get into here, so we are going to try to go in here. But right after that, instead of rolling another 2 or 3, 4, 5, 6, we actually roll a 1. What's going to happen here is we didn't count that as a 1 or as an other. And the reason for that is because this shouldn't be here at all. For this code to be correct, this extra check after the else shouldn't be there. So if the question was how to fix this code, it would basically be this. You would just make it an else. But that's not what the question is asking. The question is asking which of these things will be true in the bottom. So it's actually going to be pretty similar to the previous question we did. So the easiest way to actually resolve this problem is to see whether we can basically contradict any of these. So let's look at the first one. The first one says the sum displayed will be 10. So basically saying, oh, we know that the sum, that the value of sum here, which we calculated up here, is always going to add up to 10. Now, if this code was working correctly, that would be the case, because as we showed earlier, it's either going to be 1 or it's going to be something other than 1. But we showed a counterexample where that's not the case. Let's go through an example again. Let's say, for example, that in the very first case here, we rolled we rolled a 2, and then over here, instead of just counting that as an other, we ended up rolling a 1 by accident, because we weren't really supposed to roll the second dice right here, but we did, and we rolled a 1. That's not going to count it as other. Now, if everything else goes according to plan, what we might get, let's say we roll 2 1s and then everything else goes just fine, we might get a total of 2 over here, we get 2 1s, and then we might roll 7 other things. But we had this one case at the beginning where this got rolled into a 1, so we didn't actually end up adding that as an other here. So basically we found one case where the roll for that iteration of this is not going to actually get counted at all. So the sum in total there will not be 10. It'll be 9 in this case, or it could be even less than that. We don't have a guarantee that the sum will be 10. It could be 10. If everything goes fine, it could be 10, but it's not a guarantee. Now, on the other hand, as we just mentioned, it's not necessarily always going to be lower than 10, because if everything goes fine, the sum will actually be 10. For example, let's say we always roll a 1. In that case, what we're going to have is 10 1s and no others. And 10 plus 0 is 10. So we found a case where we can end up with a number that's not lower than 10. And also, the sum will always be greater than 1 or other. That's also not true, because in this exact scenario I just presented here, if we always get a 1, and 1 has a value of 10, then sum will also have a value of 10, right? Sum will be 10. And what that means is 10 equals 10. So the sum is not greater than 1 or other. Sum is exactly equal to 1, which means that the only answer left here is D. It's not possible to know what the value of sum will be. So this is a good example where you want to make full advantage of the multiple choice to see if you can disprove any of these, cross them out, you can get to the final answer. All right, let's do another one. So here we have a procedure called capabilities. And it takes this parameter called age. And what we're going to do is we're going to check the age, and we're going to tell you whether you can drive or vote and drive, or neither, based on what the value of age is. That seems pretty straightforward, but we can see there's actually a bug here. This is the type of problem that asks you, here's some code that's supposed to do something, but it doesn't, and how would you fix it? First, let's figure out what's wrong with this code. You can see that if you are 17 years old, it's going to say you can drive, and it's not going to say you can vote, because you need to be 18 for that. It's shown right over here. And that's correct. That's basically how it's supposed to work. But what happens if you're 19 years old? If you're 19 years old, the expectation would be that we would say you can vote and drive. But what we're actually going to see is once we enter this procedure, if age is 19, before we even have the chance to get to this point, we're already going to be going inside this if statement right here, because 19 is also greater than or equal to 16, right? So if you are at an age where it should say can vote and drive, we would instead only output can drive. So the answer to this seems pretty clear cut. You basically have to reverse this block and this block. These have to be reversed like that. So this has to go here, and then this block here has to go over. Now the way that they present this over here, or rather the way I present this because I wrote this, is actually going to be answer A. You can see that answer A is to switch lines 3 with 7 and 5 with 9. So switching 3 with 7 would basically make this check for age is greater than or equal to 18, right? And this would become 16. And then switching lines 5 and 9 would basically make this this line over here, and then this would be this line. So it would say, basically we're switching this whole if statement and this whole if statement. If we do that, we'll see that if you are 19 years old, we would end up doing this first, right? Because the check here is whether you are 18. And if you're greater than or equal to 18, it'll say you can vote and drive, because we also put that up here. And that would be the correct behavior. Whereas if you are 16, we would not end up in here because you need to be 18 or older for that. So we would end up in here. And also for the sake of completion, if you are 15 or less, you will see that it'll also work correctly. We won't end up in here because you're not 16 or older, and we are also not going to be here because you're not 18 or older. So we would correctly be returning this right here. It's worth understanding why these other ones don't work. First off, switching both of the greater than or equals to just greater than, that's not going to do anything, right? We're still going to end up with the same issue. Like if this was just greater than 16 and you're 19 years old, it's still going to end up here, which isn't where we want to be. Likewise, C is also not correct. It says switch lines 7 from if to if else, or rather else if. That's also not correct because we still end up with the same issue. If this is just an else right here, or an else if, we have the same problem, right? If you're 19, you're still going to end up over here. And you could probably already see that D is also not really helpful. Putting an else here is actually pretty much meaningless. We're going to run this line no matter what if we don't hit any of these if statements. So it doesn't matter if this has an else. And it doesn't fix our core problem, which is that if you're 19 years old, you're still going to end up in here. All right, here's another one of these problems where they give you some procedure and they tell you that it doesn't work as intended, and they ask you how to fix it. But this one is going to be revolving around lists. Let's look at this problem real quick. We have this procedure. It's called all the same. And in this procedure, we are given this list called number list. And what it tells us is if this list has all the same items, it's supposed to return true. So for example, 5, 5, 5, this is our list. This is supposed to return true. But if the list has something like, I don't know, 5, 4, 3, this is supposed to return false. It also tells us, just to keep things simple, that the list is guaranteed to contain 2 elements. So if you see a problem like this and you can't figure out why it's wrong or what's broken about it, one tip I have is that a really effective approach here is actually to try an example and to run through it and see if you can help, that can help you figure out what's broken. So let's use as an example that list 555. So we're going to start with 555. It's a really sloppy 5 there. And we're going to go through this line by line. So this is going to be our number list right here. I'm going to call it N for number list. And I'm going to keep track of all the variables. So I'm going to keep track of first. I'm going to call that F for first. And remember, in this exam, it doesn't matter whether you did JavaScript or what for your curriculum. In the exam, all indices are 1 based. So it means that the first item in the list is index 1 instead of 0, which you might be used to in some languages. So first is going to be the first item, which is this one here. This is index 1, this is 2, and this is 3. So the index 1 is item 1, which is the value 5. So that's the value of first. And index is going to, call it I. Index is going to start out at 2. And we're going to keep repeating this until index is greater than the length of the number list. So length of the number list, this is 3, right? Call this 3, because that's how many items are in the list. So we're going to keep doing this until index is greater than 3. So 2 is not greater than 3, so we're going to continue. And the first thing we're going to check is if number list of index is not equal to first. So number list of index is 2, so that's this guy right here, 5. So 5 is equal to first, right? Because first is 5. 5 equals 5. So we do not go into the if. Instead, we go on to the line right after the if, which is this one, return true. Now in this case, this worked just fine because in this example, it just happened to work with a list where everything looks the same. But let's try a different list. Let's try this list right here. Let's try about 5, 5, 4. Now you might have noticed when we ran through this in the previous example, we didn't even check the entire list, so something's clearly wrong. So let's see with this example. This is an example of a list where we should be returning false because this item's different. But let's see what happens when we actually run through this. So just as before, we're going to do the first index. The first item here is going to be the first item, F, and index is going to start at 2, right? And we are going to start this out. We're going to continue going because index 2 is still not exceeding the list size, which is 3. Number list of index, remember this is 1, 2, 3. So that would be this guy right here. 5 does equal 5, right? So we don't go into the if. We go into the line right after that, which is return true, and we return true. What's the problem with that, though? We return true without checking the entire list, and we notice that we return the wrong answer because we should be returning false. This is not a list where all the items are the same because this third item is actually different. It's 4 instead of 5. So by using this example, we found a case where we're actually getting the wrong answer because we exposed that we are returning true way too early. As long as the first two items are the same, we are returning the wrong answer. The reason that's happening is because we should only be returning true after we have gone through the entire list. So we have to check all of the items in the list before we are ready to declare that, yes, all the items are the same. So what we're supposed to do is we're supposed to iterate through the whole list, right? And if any of the items are different from the first one, we return false. And after we went through the whole list, only then do we return true. We do that over here, right between lines 12 and 13. So to do that, we would want to swap lines 11 and 12. That's the answer right here. So let's go through some of these other ones. Changing lines 4 to index 1, this doesn't really do much because all we're doing here then is if we had 5, 5, 5, all we're doing there is we are checking if the first item is the same as the first item. We already started with the first item. It doesn't, like, we don't need to check the first item against itself again. We can start with the second item, right? We're just checking that everything is the same as the first item. So that doesn't really help us. It doesn't break the code, but it doesn't make it, it doesn't fix the issue. Swapping lines 9 and 11, basically that's suggesting that these are the wrong value. That's not correct either. Like if we return true that the items are the same over here, like if this were a return true, that would clearly be wrong because what we would end up doing here is if this was 4, this would immediately return that they are the same as soon as we find items that aren't the same, which is the opposite of what we want. So that's not correct. And this one's here saying to use not equals instead of, or to use equals instead of not equals. That's also incorrect for the same reason as B. It's actually doing the opposite. It's telling us the items are not the same as soon as two items are the same. So that's not what we want. The only answer here is D. Here we have a pretty common type of problem where it's going to give you some kind of procedure, and it's basically going to tell you, like, all right, describe what this procedure does. Like, what is expected from this procedure? Here, this one's called compute, and it's going to basically do some stuff, and we have to kind of figure out what it's going to do and then say what it is. It's a little different from some of the other problems, which are like, all right, how do you fix this? Or like, what is the return value for this value? Or anything like that. This one's can be actually pretty tricky because you might not understand just from reading the code what the intent of this procedure is. However, there's a pretty good trick you can use for a problem like this, and that is similar to the one we used in the previous problem, which is try out some values. So in this one, it actually says that the parameter n is going to be an integer that's greater than 2. So let's try the next best value. Let's try 3, just the smallest possible value that is still within the bounds. So we're going to say that n is 3. What I'm going to do next is I'm going to run through the code. I'm basically going to go line by line, and I'm going to keep track of the value of the variables as we go along. So r is going to be result, and r is going to start out as 2, and j is going to be j, and it's going to start out as 2. And we're going to repeat until j is greater than n, which means we're going to keep going until j is 4. So, all right, j is still not 4. So result is going to be result plus 2. So that becomes 4. And j is going to become j plus 1, which is 3. All right. And now we're going to keep repeating because j is still not 4. So result is going to be result plus 2. All right, that's 6. And j is going to be j plus 1. All right, that's 4. All right, now do we keep repeating? Well, now j is greater than n, right, because j is 4 and n is 3. So we are not going to repeat anymore. So now we can return the result. Our result is 6. So what is 6? So if we return 6 as the result, what does that say about the result compared to n? Well, first off, we definitely terminated because we returned a result. So it doesn't loop forever. It definitely is not n times n because that would be 3 times 3, which is 9. And 6 is not 9. 6 is definitely 2 times n. So that is a prospective answer. And 6 is definitely not n because n is 3 and 3 is not 6, so it cannot be D. So between these answers, we found one case where we can get 2 times n, and in that case, none of these other ones are correct. All right, now here's a pretty common problem type. Sometimes you'll have like 2 or 3 of these in an exam. I've even seen an exam with 4 of these. And that's basically you have a robot and you have like a grid and you're moving this robot in this grid. So this robot's basically going to be moving, like it's going to be moving up, and then it's going to turn right, and then it's going to move forward and forward. And basically you're moving this robot along this grid until you get to this gray square. Usually these programs are going to be testing your ability to understand loops and conditionals. So you're going to be doing some kind of iteration, like we see it right over here with this repeat until, and then we're going to do some conditionals, and it's going to see, do you understand like how if or if else or else are different in different circumstances? Or also, just as importantly, whether the order in which things happen, which is sequencing, matters for this. So this is basically a test of sequencing, iteration, and selection, which is also one of the only times where sequencing is actually even brought up. So my number one hint for anything that has anything to do with a robot, any problem about a robot, and I cannot stress this enough, do not try to do it in your head. Use a visualization. So one thing you can do is you can kind of draw on the grid, but you're going to have to do that 4 times and you're going to have to keep erasing it. I don't recommend that. Instead, what you should do is use your pencil. Just use your pencil, like kind of lay out your pencil as if it was the robot like this, and then move the pencil forward and turn the pencil when the time comes to rotate the pencil. So I'm going to use this little picture of a pencil to simulate me actually putting the pencil on top of the grid to visualize each of these movements. So what we're going to do is we're going to do the steps in each one of A, B, C, and D until we have reached the goal, which is this gray square right here. And the A, B, C, D are going to replace missing code over here. But we're going to keep repeating until we hit the gray square, or in some of these cases, we're going to actually loop infinitely. Actually, what this question is asking is the inverse of what you'll usually see. This is actually asking which one of these is not getting you to the gray square. Which one of these is going to loop infinitely? Which is kind of, you might read this, if you don't read it carefully, you might find that A gets you to the gray square, and then you'll circle A without being careful, when the question is actually asking which of these does not get you to the goal, right? This is asking which one will cause the above code segment to loop infinitely. So read the questions carefully. All right, let's go through this. Let's look at A. So A, we're going to move the pencil as follows. We're going to see if can move forward, we move forward. So we can move forward, so we do it. If can move right, we rotate right. We cannot move right, so we don't do that. If can move forward, all right? We still can't move right, so we just keep going. If can move forward, move forward. If can move right, then we do rotate right. So now we rotate our pencil to the right. If can move forward, we move forward. We cannot move right, so we don't do that. Notice that I'm facing the right, so can move right means right relative to the pencil, to where the pencil is facing. So this is actually not going to rotate. It's going to keep going forward. And then finally, if can move forward, move forward. It cannot move right, so it doesn't do that. And we are at the gray square, so we stop right here. And we've shown here that since we do get to the gray square, we stop the program, we do not loop infinitely. The answer is not A, because we want the answer that loops us infinitely. Now B is going to be very similar, but we're going to check if we can move right first before we move forward. Just as before with the pencil, we can't move right, so we don't do that. We can move forward, so we move forward. Can't move right, so we don't do that. We can move forward. We can't move right. We can move forward. We can move right now, so we rotate right. And then we move forward because we can do that. We cannot move right, so we don't. We can move forward, so we do that. And now we are at the goal, so we stop here. So that means that this is also not the answer. We reached the goal. All right, now let's look at C. C is going to actually be our answer, and we'll see why. So now we're going to do the following. We're going to go through just as before, but we'll see that something's a little different here. So we're going to say, we're going to check, can we move forward? We can, so we're going to move forward. But notice that here we have an else, so we don't even try to evaluate that. We don't even try to see if we can move right. We just move right on to the next loop. So we can move forward, so we do that. We don't try to move right. We can move forward, so we do that. We can move forward, we can move forward. And now we're all the way at the end. We can no longer move forward because we're all the way at the end. So now we hit that else. And now we're facing this wall, so we still can't move forward. So we hit the else, which is going to make us rotate to the right. And now we're facing straight down, and it's actually going to repeat just like before. We can move forward, so we do so, and we do that all the way till the end until we reach the end. And now we are facing this wall, so we can't move forward, so we turn right. And we're facing the wall, we can't move forward, so we turn right, and we're right back to where we started. And we're going to keep just looping up and down, doing this over and over again. And that is showing us that we're going to be in an infinite loop here, because we're never going to stop. We're never going to get out of this little narrow hallway. So this is the answer. Just for a real quick evaluation, this last one, D, this is going to be pretty similar. I'm just going to draw this one so I don't have to edit this pencil moving up and down. But basically what this is going to be, it's going to be a lot like B, except this if is actually kind of pointless for these, because in both A and B, we were always moving forward on every step. There was never a situation where we couldn't move forward. So not having to check before moving forward doesn't matter for A or B. So it's also not going to matter for D. So basically, we're going to check if we can move right. We can't do that. So we're going to go forward. We're going to check if we can move right. We can, so we move forward. Check if we can move right. We can, so we move forward. Check if we can move right. And now we can move right, so we turn to the right. And we're still going to move forward. And we can't move to the right, so we just move forward. And then we end up here. All right, and that's it. That's how you do these robot problems. You can probably move a lot faster than I did here because I had to explain this. Generally, these you can solve pretty quickly just by kind of using your pencil to simulate the robot moving around. And I think those should be pretty straightforward. You should kind of hope to see these. I honestly find these to be generally not that challenging. All right, I saved the hardest one for last. This is the type of problem that can be pretty troublesome. Sometimes the most challenging ones are of this format, which is they're going to give you some procedures you may or may not have seen before, and they're going to ask you to solve some kind of problem with them. In this case here, we get these three procedures right here. We get this substring, we have this concat, and we get this length. And basically it's going to say, all right, how would you use these to solve this problem, or rather, which of these can be used to solve, to actually implement this procedure that we describe right here. What makes this tricky is that sometimes you'll get a procedure that you haven't seen before. Although if you practice a lot, you might become familiar with these, like substring gets used a lot, and it's actually part of a lot of programs you might have already written. Same with concat. Length is actually standard, so that one's just there kind of for completion. But sometimes you'll get something kind of creative that you may not have seen before. But as long as you get a lot of practice with how you might see a procedure and be able to read the explanation for it to understand what it's doing, and then you can kind of get some practice in using these in creative ways, you should be able to resolve this just fine. And honestly, you don't have to write any code. So a lot of times all it comes down to is, are you able to understand the explanation for it so that you can kind of figure out if the code that they present to you here is doing what it expects you to do, what this function, for example, wants you to do. Now, the main thing to watch out for here is that a lot of these will have like a start and an end, or they'll have some kind of parameter. And the arguments that you pass in as those parameters are very important because, like, you have to be careful. For example, this is substring, it's a part of the string, and you have to read carefully whether, if you have the number 3 here, for example, does that include character number 3, or is that characters 4 and beyond? And same with the 6. Does it include the 6 or not? So you have to read the instructions carefully because it tells you, basically, it says the character at position start and the character at position end. Sometimes that's not going to be the case. Sometimes it'll be like, if you say delivery and then you pass 3 and 6, it might not start with character 3. It might start with character 4. So just be very careful on that. In a sense, these problems are about libraries. That's kind of what they're going for here, is this is the library. They're giving you a library. And it's kind of on the topic of you can use existing code to solve problems. But most importantly, it's testing procedures and parameters. That's what we're going with here. But in this case, it's also testing strings. So there's a lot of stuff going on, also variables. There's tons of different topics getting included. Anyways, let's get to the program. Let's get to this actual thing. This problem has this function called echo, or this procedure called has echo, and you give it some tests, and you're supposed to return true if it is an echoey text, and false otherwise. So it's defining echo here as something that's the same text repeated twice. So like Lulu, it's L-U, L-U, or yo-yo, it's yo-yo, or this right here, which is O, followed by the same string, O, or echo, echo. So as long as it's the same string twice, it's supposed to return true. And for anything else, it's supposed to return false, like hello, or even this one here, yoi. This is the same string, but it reversed, so that doesn't count. So it has to be the string and then that same string in the same order. So the key here is we have to use substring, concat, and length creatively to resolve that. But they actually did that for us here, so we just have to see whether we have to, this one has two answers, by the way, and we have to figure out whether these will fulfill this by putting them in the rest of the code. And we want this to work for all even length inputs. Notice that all even length inputs right here. Sorry, I covered the text there, but basically it has to work for any inputs, not just these examples up here. They did simplify this a little bit by telling us that the inputs will be of even length. So it's going to be 2, 4, 6, etc. So we don't have to worry about odd inputs, which is nice. So let's try this out. Let's see if A does what we want. So A is going to take the substring for text. And let's use this example to start out. Let's say Lulu. We have Lulu as a string. So it's going to get these two variables, left and right. And left is going to be substring of text starting from characters 1 to characters 2. That's these two. So this will be left. And right's going to be index 3 to 4. So it's going to be 3 and 4. So this right here. So basically left is LU and right is LU. That's all good. And it's going to return left equals right, which means it's going to return true if left is the same as right. And in this case, it returns true. However, that's not a correct answer. And the reason for that is because if we try any other input that's bigger, so how about this one right here? Let's say Lu. Left is going to be this, and right is going to be 3 and 4. So 3 and 4. And LU is not equal to UL. So even though this whole thing should return true, because this is, two strings that are repeated, this will not give us that because it's only checking the first two characters versus the characters 3 and 4. So it's basically ignoring the rest of the string. So just with an example here, we see how this one's not right. Now, B is doing a whole lot of other stuff. So this one gets a lot more complicated. Let's take a look. So B is going to be using this length thing here. And length of text, let's use an example like Lu. Let's use Lulu here. So length is going to be how big the string is. So this is going to be length of 4. And we're going to divide that by 2. And luckily, since we have even length inputs, it's always going to be a even number, or always going to be a non-fractional number. So in this case, this right here is just going to be 2 because 4 divided by 2 is 2. So we're going to go from characters 1 to characters 2, just like before. And here, this is going to be that plus 1, so 2 plus 1, right? Here's length of text divided by 2, and we're just adding 1 to that, so that's going to be 3, all the way to the length of the text, which is 4. That's these two right here. So length, left is this, right is this, and we're going to return whether left equals right. So this one gets us the right answer. But just for good measure, let's try that on a bigger string like this one here, Lulu. And we see that this right here, the text has a length of 6. So 6 divided by 2 is 3, right? And this right here will be 4 because we have 3 plus 1 is 4. And the length here is 6. So we're going to go from 1 to 3, that's this. And then we're going to go from 4 to 6, 4, 5, 6. So Lu does equal Lu. So this will give us the right answer. This is one of the two answers. Right? Now, you might look at that and say, well, I just found 2 cases where it works. How do I know that there isn't some case where it doesn't work? And that's a good point. We don't. However, as long as we can find some point that makes one of these not work, we can count it out. So we can use that to assess, for example, whether one of these other ones is wrong. And if we can eliminate the other one, we know which two are correct, because we already found a case where A doesn't work, right? So for all we know, B might still be wrong. It's not, but it could be. But let's see if we can find if one of these other ones is wrong. So let's check C. So this one's a little different. It's going to use concat, and instead of checking left and right, it's going to do something different. So let's see what it's doing. So left is going to be so we're going to do Lu. Let's do the same thing, Lulu here. I don't know why I keep using that string. And this is going to go from 1 to the full length of the text, right? So this is a length of 4. So left is going to be the whole thing, right? It's going to be 1 through 4, which is Lulu. And then full is going to concat, which combines two things. It's going to combine left and left. So full is actually going to be Lulu. This is full right here. And it's going to return whether full equals text. In this case, we already know that is just not correct because it's returning false, because Lulu is not the same as Lulu, right? We're comparing Lulu to Lulu, and that's false. But we know that this is supposed to be true. So we already found, just with the first case, we already found an example where C is false. Let's try out D, though, to figure out why it is true. So D is kind of doing a creative thing here. It's saying left is going to be, if we do Lulu, it's going to be just the first half, right? So we're going to do Lulu right here. And it's going to basically go from 1 to half, like it's going to basically grab the first half of the string. And then it's going to say, all right, left, I'm going to replace the current value of left, which is just LU, with itself repeated. So it's going to, left is now going to become left concatenated with left. So this is left. Left is going to become this, right? Left and left. So basically we're just duplicating the string. We're just concatenating it on itself. So now this is left. And we're going to check whether left is the same as the text. And the text is Lulu, and it is true. And if you try this with a couple different examples, you'll see that this will always work. And it works because basically we're just checking if the first half of the text is going to be the same. If the first half repeated is the same as the full text, which is always going to be the case if this works. You can also see that it's going to give us the right answer if it doesn't, like if it's one of these, for example. So like if I take yoi, and I take the first half, and then I duplicate that, so I go yo, I see that yo is not equal to yoi. So it returns false, which is the correct result, because this should be returned false. All right, and that's all the problems that I put together for this. I think if you practice these problems, these are somewhat tricky. This is a good mix. Some of these are pretty simple. Some of these are a little trickier. I think this last one's a little on the trickier side. But if you practice these, you'll get a good amount of experience with the necessary skills like iteration, conditionals, lists, things like that. And generally, you'll see problems will fit this kind of pattern. It's not going to vary too much from this. So as long as you get some practice with similar problems, you should be in pretty good shape.